Hello everyone, my name is Maria Fernanda Fajardo Nava and today I'm going to present my project about custom Wazuh rules for detecting ransomware, phishing, Trojan and denial of service attack on Windows 11. This project was developed for Incident Management and Response Laboratory with Professor Angel Pech. First, let me explain why this project is important. By default, Wazuh has many rules already included, but these default rules are not always precise. Sometimes they miss real attack or they create too many false alarms. So, in this project, I create custom rule for 4 types of attack: ransomware, phishing, Trojan, and denial of service or brute force. All of these techniques are mapped of the MITRE ATT&CK framework, which is a standard way to classify attack. My main objects were install Simon on the Windows 11 machine, create customer detection rules in Wazuh, reduce nodes in the data, control false positive, set up the later notification, and test very single rules with a real event. Now let's talk about the lab environment. I use a Windows servers running on Linux with the manager, the indexer, and the dashboard version 4.45. The endpoint was physically Windows 11 computer with the Wazuh agent installed and activated. Both machines were connected to the same local network. Before creating any rules, I used to check that the agent was really connected, and I used this command. As you can see in the screenshot, the results show 2 agents, the server itself and the Windows agent called Mafferwin, which was active. This confirmed that everything was ready to continue. The next step was installing Simon. Simon is a Microsoft tool. It is very important because it gives us detailed information about every process, including the full command line. Without Simons, we cannot see this level of detail. I installed it with the command using a configuration file called config.html. After installing it, I configured the screen version and I checked that the Simon 6.4 service was running using the get service command. This is a key point. All of my customer rules depend on this event that Simon generates. Specifically, they use 2 groups: Simon event 1 for process creation and Simon event 80 for register challenge. Here you can see the Simon configured file. I configured it to log 3 types of event: process creation, every new process that starts; networking connection, outbound and inbound connection; register event, challenge in the Windows register. In this configuration means that nothing is excluded, so all events of that type are captured. This gives me maximum visibility for detection. Before writing any rules, I also modify the agent configuration file. This step is called ingestion tuning, and it is very important to reduce noise. I configure 3 things. First, the log channels. I collect Simon operational log and security logs, but I filter out to noise in events ID 4658 and 4690. Second, I add labels to identify the environment and the responsibility analysis. 3. I create a deco folder called Señuelo Ransomware. This folder is monitored in a real time. If ransomware starts encrypt files, this folder works like an early warning system. Now let's move to detection rule. I will start with ransomware, which is level 30, the high severity in my rule list. I create 2 rules. The rule 100250 It delays the shadow copies so the victim cannot recover the field using Windows built-in recovery. The rule 100251, when they try to delay backups or disable the recognition option. Both rules check two things: the process image and the command line text, and both require the Simon process creation event as a condition. Because these patterns are so specific, they are also the most related rules in my entry project. They had almost no field positive during testing. Next is the phishing rule, level 12. Rule 100350 detects when a Microsoft Office application like Word, Excel, PowerPoint start command interpreter like PowerShell or CMD. This is very common phishing pattern. It usually means a malicious macro inside a document just executed. However, I want to be honest, this way to rule with the most file positive in my project. Some legitimate authors create also an open office application, and this can trigger a false alarm. Now, Trojan detection, level 11. I create two rules here. The rules 100550 detect when an excuse files room for a temporary folder. This is a classic technique used by droppers, a small program that double and install the real malware. The rule 100560 detects written to the Windows root registry key. This is a common way for malware to achieve persistence. It is stay active every time the computer is started. Together, these two rules cover two different states of a Trojan attack. First, the delivery, and the second, the persistence. Now, let's talk about denial of service or brute force detection. Rule 100450 triggers when there are a authentication failure within 120 seconds. This result indicates an automatic brute force attack, not just a normal user who forgot their password. Testing was a critical part of this project. I validated every single rule using a real event, not just theory. First, I confirmed that the agent was really sending data using share for agent name Mafferwin in the discovering section. This returned 363 hits, confirm a strong connection. Second, I simulate real attacks. For example, I execute commands in PowerShell, and I also simulate the phishing and the brute force scenario. 3, I confirm the alert appeared correctly, searching for the specific rule ID. As you can see, it's generated exactly one hit, a very precise detection, which no extra noise. During this testing process, I also discovered important issues. The rule field need the prefix data. For example, data with event data images. Without this prefix, the rule simply not to work. This was on my biggest learning. To respond faster to critical alerts, I configured a Telegram integration. Any alert with level 12 or higher send an instant notification to my phone using a small Python script. During testing, I successfully received a level ransomware alert directly on my phone. I also want to display my severity levels. The level 30 is critical. The level 12 is high. The level 10 is medium. A level 0 means it is no false positive. To conclude my presentation, I most reliable signal in this whole project was the ransomware detection. Rules 100250 and 100251. Their patterns are very specific, so they produce almost no false alarm. On the other hand, the phishing rules produce the most false positive, and this is an area for future improvement. I also learned that file meaning is critical in Wazuh. The data prefix is required for Windows event files. And finally, testing is mandatory. Every single rule must be validated with a real event before we can trust in a produced environment.